Today we are going to be first introducing you to who is Petuum and our approach to artificial intelligence. We're going to share with you how we currently integrate with OSI Soft. And we're going to keep this part of the presentation pretty light and fast. The main thing I want to show you today is the technical demonstrations. And so keep in mind, we do have a good number of folks on the call today. All of you have different backgrounds spanning from metals and mining to oil and gas. And so our demos are really based on the core elements of artificial intelligence. And we'll be talking through about how these may apply to your business. But I really want you to start brainstorming and thinking, because everyone on the phone today is going to have a different approach for how they think that this could apply to them. And then lastly, we're going to have an extended question and answer session. And I'm joined with two of my colleagues today, Victor and Ben. There we go. Would you folks introduce yourselves quickly?
Sure. My name is Victor too. I head up marketing at Petrol. I've been with the company for about a year and a half. Super passionate about the technology, and look forward to sharing a little bit more information about what we do.
Yeah, my name is Bing Zhao, and I've been with the company for about 1.5 years. So my background is in machine learning. I got my PhD from Carnegie Mellon, working focused on time series and computer vision. And right now I'm serving as VP of machine learning for Petrol. So I lead the machine learning efforts inside Petrol.
Great. All right, we're going to go ahead and get started. And Victor, I'll hand it over to you.
Great. Thank you. Thank you, Christina. So first of all, welcome to this workshop. We are excited to share information with you. And the reason why we are very passionate about AI is really because we see AI from talking to customers, from talking to different stakeholders. We understand that AI is actually quite hard. And in fact, according to Gartner, 85% of AI projects fail. And because of that, our founders have actually wanting to solve these problems of how we can make AI more accessible to everyone. So just a little bit about Petuum. So we are founded by Eric Xing and Shirong Ho. They are both from Carnegie Mellon universities. And in fact, Eric is the associate director for AI ML studies at the Carnegie Mellon universities. The reason why he founded this company really because of two things. When he was on sabbatical a number of years ago, he realized that building AI applications is extremely hard. There are different tool sets out there, and all those different tool sets do not necessarily help in accelerating the development of AI applications. So he wants to make something that can allow people to adopt AI very quickly. And the second thing is, even if you know how to build AI applications really well, the foundational elements such as the operational, how do you make your AI application scale? How do you make it function? Because it's so different from traditional software. He basically found a way to change the paradigm on AI. So what does that mean? So a number of years ago, it doesn't matter how many compute resources you throw at a machine learning training, it will just not scale because it hits the plateau. He basically able to break that paradigm, and using commodity hardware, using new methodologies with distributed learning and parallelization, he was able to come up with a breakthrough to allow machine learning to scale infinitely with more machines added to it. So that's one of the greatest breakthrough that he wants to bring to enterprises so that they can adopt AI applications. So we are lucky enough at the company we have over 50 top AI talents with PhDs as well as master's degrees from top universities, including CMU, Stanford, Berkeley, and so on. And we are also backed by some of the top tier investors in the world. Just this past year, we received a number of awards, including the Cement Industry Awards, along with the other innovation awards that we have received over the years. So just how do we externalize and make AI more usable for everyone? We can look at this from a 3-layer cake standpoint. So with the platform, we allow AI to scale. With the accelerators, we allow anyone who has a software engineering background, but maybe some ML expertise to use our AI accelerators to assemble AI capabilities into your own software applications. And then for customers who wants to use a pre-built solutions or product from us, you can actually take that and use that today. So in the 3-layer cake, the Orchestra platform really comprises all these capabilities. And the Orchestra platform is really built for ML engineers. AI accelerators is built for software engineers. And then industry solutions is really dedicated for customers who want to get to production quickly without having to build everything from scratch.
Great, and I do actually have a polling question on the previous slide, Victor, for everybody.
Sure.
So I'm going to launch this here. So we are asking, based on your organization, which one of these 3 layers do you think you would value from the most? Are you more so looking for an AI platform? Are you looking for AI accelerators or those building blocks that Victor was mentioning to help augment your own team's AI talent? Or are you looking for end-to-end industry solutions to basically bring your ideas through to production or fruition? We'll give you just a few more minutes here. Not a few minutes, a few more seconds. Get your votes in. Okay, great. It looks like, I'll share this for a second. Only a few of you said the platform, and then as we go up the chain to industry solutions, more and more people are interested. Great feedback, guys. All right, Victor, back over to you.
Great, thank you, Christina. So let's start off by looking at what the platform looks like. The platform is very comprehensive. This is actually a view for our ML engineers. The top element here, this is actually what we call internally as a subway map. This is basically how our ML engineers can actually use all of the blocks on the left-hand side and build an ML model. And what you're looking at here is just a very simple ML model, but it can be as complex as it can be. One of the unique things that we are going to provide is, especially at the accelerators level, you'll get this complex subway map, so to speak, so that when we release Orchestra sometime later this year, not only do you get the platform where your ML engineers can actually build the ML applications from scratch, but you can also go in and tweak the accelerators. We will pre-package quite a number of accelerators based on industrial use cases, so that you can take advantage of some of the top AI talents, expertise, where we have assembled some of these elements for you and allowing you to make the necessary customization. So we'll show you a little bit more about this later. Next is also very important. I think many of you are here because of the OSI and PI world connection. We have a connector which allows us to integrate between the PI system as well as Petrol. It allows us to take in historical data or even streaming data from different systems, including PI, and allow us to make a lot of very powerful capabilities and integrate into your productions environments. So this is just a sample architecture in terms of how we work with the PI system, as well as how that integrates into your control system and your environment. So with that, we're going to jump into some of the more exciting elements in the machine learning demonstrations. The 3 core expertise that we have at Petuum, which we are also building into the platform as well as our AI accelerators, really comprise of these three elements: computer vision, natural language processing, and complex decisions. And these are, and the 50 top engineers that we have really comes from these three areas. And the demos that you're going to see today will also be about these three elements. So first, let's talk about complex decisions. And this is where I'll have Christina share a little bit about our Petuum Optimum product, which is our industrial AI solution.
Sure. So Petuum Optimum, it can be applied to a number of different businesses or applications. But basically, as the name suggests, what we're doing here is we're optimizing something. And so there's a number of different steps you have to take in order to reach that level of optima or get reaching your goals. And so in this particular instance, this is with a cement customer. Over on the right-hand side, you can see the UI of one of their assets, as well as on the bottom screen there, that is actually a PI Vision graph where we are mapping out the predictions and prescriptions and then the actual values of a cement clinker cooler. And so what the main goal here is to help augment those operators who are making decisions in real time. And so rather than just relying on their experience, their training, their understanding of these processes, we're actually learning from the data, and we're learning from a number of different operators and shifts. And so the first thing that we do here is we're understanding how all the process variables interact with one another. And so we're building a neural network, we're understanding the correlations between all of these things going on. Once we're able to do that, then we're able to predict or forecast what's going to happen in the future. And so we do this for our cement customers up to 30 minutes ahead. Clearly, the longer out in time that you are predicting, the less accurate they're going to be, because there's a number of different inputs or things that could change. But sometimes also, like aside from cement production, people who are using Petuum Optimum can use just the correlations in the predictions layer. You don't necessarily need to go beyond that. But for this customer, this example here, we're going all the way to what we call supervised steer, which is a closed loop solution where we're not only just predicting what's going to happen in the future, but we're actually prescribing what the best actions or set points would be in order to reach your business goals. And so after we understand what's going to happen in the future, we work with our customers to configure or personalize what their goals are, what their static and dynamic constraints are, and then being able to write back to their equipment and their control systems what action you should take. And in the supervised steer, that's all happening autonomously with the operators overseeing or supervising what's happening on the floor.
Great, thanks, Christina. So with that, let's actually jump into a live demo. So my team always warned me about live demos, but I tend to like doing demos live. So if something were to happen, you can blame me. So this is actually an Optimum dashboard. You can see here we have a lot of information. We're just going to go ahead and explain to you what you are seeing here. So quickly scroll through the environment just to give you a quick overview of what the dashboard contains and what the informations are in there. So if we go back to the top, what we are seeing here is really the status of the Optimum system. So we are connected to a environment where it allows us to do what we call supervised steer. So supervised steers allows us to provide a semi-autonomous mode controlling the assets of our customers. So this is based on a lot of testing, a lot of validations before the customers would actually enable us to autonomously run their asset. And even while running the asset, the reason why it is a supervised steer is because the human in the loop is super important. We make sure that the operator has the opportunity to monitor what's going on. Once the system is operating, if there's something that requires an operator to take an action, they can. So in this case, let's take a more detailed look at the environment, maybe a specific time period. So September 14 to 18 time period. So you can see here there are different diagnostic that happens, including a product heartbeat, And you can also see what the first thing that we have in terms of the prediction area. And the prediction area is really the first step in how we are achieving this AI capabilities for our customers. So if you look here, there are 4 different elements that we are trying to optimize based on the types of asset a customer has. So we have the temperature objective, where in this case, we need to minimize it. The secondary temperature, where we need to maximize it. The undergrade pressure and tertiary air temperature, and so on. So what we are really doing is based on the value, based on what's happening with the asset. As Christina mentioned earlier, we will predict out 5, 10 to 30 minutes out into the future on what's happening with that particular asset, whether it's temperature or pressures and so on. And in this case, what you see is we are actually making adjustments based on the information that we are predicting out into the future. So for example, on the left-hand side, the objective is really to minimize temperature. So traditionally, the temperature might be around 148 degrees Fahrenheit, but based on our system, we were able to minimize the temperature in order to have the system run in an optimal manner. So similarly, as you see in this chart, you can see all of the different information on how we are trying to achieve that goal. You can also click on different numbers just to see how we are predicting, how we are forecasting, as well as what is the actual real-time value. So the next area is what we call prescription. Now that we can predict out into the future what will happen to your asset, and now we are providing recommendations on how you should adjust the temperature or how you should adjust the different controls in your environment. So what you see here, there are 4 different elements that you can adjust. You see 3 fan flow adjustment, as well as a stroke speed adjustment. So in this particular area, based on the objectives above that you see, we will actually make recommendations on how the operator should adjust their control flow in order to optimize their assets in that particular environment. And so what you see here are 4 different criteria that we are providing prescriptions on. And all of this information is being fed back into the top level when you saw what you saw earlier with the supervised sphere. So if the operator basically just want to see the prescriptions, they can, and they can, based on the prescriptions, based on the recommendations that we provide here, they can manually adjust it, or they enable the supervised steer mode, where we will actually write back to the control system directly, and based on the prescriptions here, we autonomously automate the asset. So that's the first demo on the Optimum side. And let's now jump into a real life demo with regards to Orchestra. So this is—
While you're pulling that up, I just wanted to make a quick comment. So clearly that example is very specific, but I want the audience to think we could do similar, we could use similar models for the predictions and the optimization on a lot of different things. So you might have different assets or processes. You might be trying to optimize yield, energy, throughput, even quality. And so there's a number of different applications of how we can use that product framework and these models for different types of businesses as well.
Yeah, great. So I want to jump into very quickly on Orchestra. So this is the subway map that we talked about earlier. Basically, this is a complex flow, and this is actually built by one of our ML engineers in order to solve one of the more difficult challenges. And on the left-hand side, you see a series of different what we call blocks, different building blocks. You can see all the different functions, AI functions and elements that you can pull, sort of drag and drop, and build your own ML applications. And the way that we manifest this application is using an API. So the Optimum product that you saw earlier is really an engineer building a very complex flow using multiple models and so on, and then connecting it to the dashboard that you see earlier, as well as later on connecting to the PI system, all using the API serving mechanisms that we put out there. So this is a very quick overview of Orchestra. Something that you will have access to later on in the year with this entire platform, as well as the AI accelerators that you see here. So with that, let's actually go and take a look at some of the AI accelerators. Christina, you have something to add?
I do. I'm just trying to add some extra comments here, Victor. So as you mentioned, this is the platform or the foundation which all of our products and industry solutions are built on top of. The great thing about the accelerators, that top, the building blocks there that you see strung together, or the platform in general, I personally work with a lot of customers who today don't have the in-house data scientists, the software engineers, but they're still trying to figure out what their digital transformation roadmap looks like and how they want to go about adopting it. And so today, say if you're starting with some industry solutions, but down the road, you're looking to build out that part of your team and bring some more expertise in-house, it's a really easy transition whenever you have these capabilities at hand. And so you don't necessarily have to start from scratch. You can realize the benefits of AI today. And then after you bring those folks on board, you can almost convert or change your business model.
Great. So let's actually jump into one of the first accelerators that we want to show you. So we are going to show you a series of different advanced AI models that are built on top of the accelerators. So some of, like mentioned earlier, there are NLP as well as computer vision related. So I'm going to jump into the first one, which is even though it is a Petrol Med solutions, but the foundational AI elements are the same. So we'll go ahead and do that with the critical information extraction. So let's go through the day in the life for a doctor. So let's say a doctor needs to go see a new patient, and in order to see a new patient, the doctor probably wants to go and read up on what's going on for this particular patient. So let me actually go ahead and pull up the information for this particular patient here. So I'll input. Obviously, this is not going to be the final product that you see for a customer, but this is a demonstration on a UI that we quickly throw together to show you what is the art of the possibility. So the two documents that I uploaded is basically a doctor's summary. So when a doctor sees a patient, the doctor will write all this different medical information about this patient and what's going on. When this person needs to go see a new patient, typically they'll only need to spend probably 45 minutes to an hour to go through what's going on with this particular patient. Well, one of the things that we are able to do is quickly summarize the medical report for this physician. So looks like this patient has, say, congestive heart failure. How do we arrive at this conclusion? Well, it's really because our system can understand text in its natural form and in its appropriate context. So here we actually identify atrial fibrillations as a potential issues or texts that are written by other doctors about this particular patient. So let's actually take a look at atrial fibrillations. We actually show you evidence on where in the medical report where AFib it has showed up. And one thing that you also realize is that how are we able to figure out AF, whether it's in the capital form or short form, or even the full written out form is related to atrial fibrillations? That's really because our NLP, natural language processing capability, understands the context of what this document is in. Since it is a medical document, we understand that this is really related to a medical diagnosis, and therefore we associate AF as atrial fibrillation instead of Air Force, for example. So let me show you another example warfarin. So warfarin is also known as coumadin in the medical terms. So the system is intelligent enough where it's able to associate different medication or combine different medications that are the same medication together under the same name. So this allows us to simplify or summarize the information a lot more succinctly for the physicians, for the users, for example. But I would like to bring Ben up here to have a quick chat to see how are we able to do this? I know I quickly talked about this at a high level from a non-ML person's perspective, but maybe then you can share a little bit insights on what's happening behind the scene and how we're able to do this.
Sure. So there are two key components to make this happen. The first one is that we need to start with a knowledge graph. So there are some work already on constructing knowledge graph for the medical space. So starting from there, we understand there are some diseases which are associated with some symptoms. So we have those information, but that's just the beginning. The challenging work is how do we expand the knowledge base automatically? So for example, if we throw a lot of text into the system, will it be able to connect the dots between arterial fibrillation with AF, is able to actually connecting the dots? So I think the second key part is that how do we make this different from just doing a command F, right? So what happened was that we are able to process all those text documents automatically without any human intervention. Basically, it's like the machine is reading through all those documents and making the connection between those different concepts, and it is enriching the knowledge graph. So at the end of the day, after reading through all those documents, it is actually the system actually has a much bigger knowledge graph, so that it is able to connecting those concepts and finding those concepts from a new document. So that's basically how we do this.
Okay. And then the next one we'll show you very quickly is the chest X-ray. So once again, we'll also upload a chest X-ray imagery. So in a number of seconds, the system will actually output the result. Interestingly enough, we actually will provide a text explaining what's happening in this particular chart. So it's not just showing you a chart and maybe giving you some medical terms, but even outputting a summary of the text explaining what you see here. Not only can we do it in English, I can actually quickly switch it into Chinese, and it will show you the same report into the Chinese language. So maybe then you can share a little bit more about what we are doing here. How can we look at an image and being able to output into a human understandable language and in multiple languages as well?
Sure. So basically, here we have two key components. The first one is what we call computer vision, which is basically teaching the computer to see images. The second part is what we call text generation, meaning that after we got some conclusion from looking at image, how do we come up with a natural language description? How do we come up with a paragraph that is describing what the computer sees in the image? So for the first part, what happens is you can think of this as a teacher-student scenario. So basically, we have a data set of labeled images where we pinpoint which area is more related to the illness and what the kind of illness it is. So we have this data and we train a computer vision system to try to identify, classify, and also localize those illness areas. And then the second part is that based on the findings of our computer vision model, then we launch our natural language processing model. It is going to be based on information found from the images, and then to come up with a natural language description of what is going on. So that's basically the two-step how we make this happen.
Gotcha. And it may look like quite weird for us to maybe show it show a medical example, but maybe Christina, what do you think? I mean, how do we apply this potentially in a industrial setting?
So I see a number of different applications, right? So being able to ingest multiple sources of text, whether it's a PDF, handwritten notes, And instead of it just residing in its individual silos, being able to learn from that information, and it becomes even stronger whenever it's coupled with imagery. And I've seen lots of examples. I feel like photos and videos are becoming more and more accessible, but there's such large files. Here you even have an example. I'm looking forward to you showing this one.
Yeah, this is an example that we have combined industrial imagery. So in this particular example, it's actually steel imageries. So in the productions of steel, there tends to be certain defects. So very quickly, once I put this image into the system, it says, well, the finding is there's a roll in scale. Okay, if there's a new employee that comes in and trying to understand what does this mean? What does this mean? We actually have an NLP mechanism. So in this case, we just build a very simple bot, and later on we'll show you how this bot can be built very quickly. So maybe we'll type in what is the types of roll in scale and see. So very quickly it'll give you an answer. So so we can combine a NLP, natural language processing capability directly into the similar app. So in your scenario, if you have an image detection issues and you wanted the operator or a user to be able to quickly find information, you can actually combine these two in a manner that makes it very usable in your environment.
Yeah, so here is a great example. You're showing images, you're showing the NLP example. Also, I imagine we could even take this one step further. If we could collect the process variables through time series information, similar to the example we showed for the cement coolers. Here, you not only are able to quickly identify the defect, but potentially also the root cause. And then once you're able to understand those relationships, being able to optimize for the production rather than waiting until you have a defective product.
Okay. Next, let's actually show another example. One of the key things that Petrol wants to do is really reduce the time for you to build an AI applications. And one of the common complaints when it comes to building an AI applications is really the data side. The model, the ML model is actually a smaller element, but being able to cleanse the data is a big problem. And one of the things that we are able to do very well is to help customers reduce the time significantly from a data preparation side. So in this particular demo, it's basically just us being able to use two imageries in order to show, in order to develop these solutions. So let me go ahead and pick a picture. I'll upload a picture. This is a picture of a retail shelf. It's basically trying to identify different objects in this particular shelf. And we only need two pictures. One is the shelf picture, as you can see here. And the second one is actually the original image of the merchandise. So as you can see, it's beginning to recognize the different objects here. And being able to do that very accurately. But maybe Ben, you can tell us how are we able to quickly and accurately recognize these images by using only just two images? I mean, I've heard from many people that in order to do image recognition, you need thousands of images before this will actually work.
Sure. So I think on first glance, this might look similar to some of the other demos I've seen before, maybe like face recognition, people identification. You're using bounding box, draw those rectangles on the target they're trying to detect. The key difference, as Victor mentioned, is that everybody is assuming that customer enterprise has big data. But based on our observation, our communication, is that often cases for enterprises, they have a lot of small data sets scattered across different departments. So they don't really have access to, say, 1 million images or even 10,000 or 1,000 images to train one classifier. Often cases, they might just have this very small amount of data. So what we do here is that we go to the extreme case where we're basically just using two images. The first image is the item that is being sold, so the item image. The second image is the shelf image that you're seeing here. So the way we do this is that we are detecting key points on the item images. Those could be things like text, could be texture, it could be the color, color distribution. So we detect those key points, and then we do the correspondence or the key point matching between the item image and the shelf image. And because we are not relying on the purely on the deep learning approach, we can actually get away from the the requirement of large amount of training data. And in this case, just 2 images. Back to you, Victor.
Yeah, what is quite impressive for me is it's able to give you like evidence. This is like, so for example, when you hover over the object, we can actually tell exactly what that object is about. And another thing that is very impressive to me when this was built is when you look at this Apple App Store card, they look exactly the same if you're not careful. So in most computer vision solutions, you probably will say, oh yeah, this is an Apple iTunes card, and probably stop at that level. But we can actually read like the denominations on the card itself. If you look carefully at the picture, you notice that this is a 10,000 yen card, and this is a 1,500 yen card. And if you are not careful, you probably just say, oh yeah, this is the same thing. But in actuality, there are 2 different denominations, and we are able to pick up on even the smallest number, smallest level of detail. So this is quite fascinating. But how is that done, Ben? How are we able to do something like this?
Sure. So basically, if you look at the different objects, the difference could be coming from different sources. So for those two examples that Victor just highlighted, the difference is mainly on the text part. One is 10,000, the other is 1,500. So our system is basically collecting information from different sources. So text is one of them. So for this example, the text difference is going to play a much bigger role in terms of determining which product it is. For some of the other products, our system might be focusing on, for example, the color distribution. It might be focusing on the texture of the product. So all those different information actually comes into play in terms of determining which product it is. And because our system is able to use such a widespread of information, we are able to separate items which might be very similar to human eyes, but their differences might be very subtle. So our system is able to pick up those small cues.
Yeah, that's great. And Christina, I mean, in the industrial area, there are probably a lot of imageries that happens where sometimes a lot of our customers probably complain that, hey, don't you need a lot of pictures? How do you see this being applied in the industrial area?
Absolutely. So this is clearly a retail example. I'm not personally all that familiar with the use case, but from an industrial standpoint, I can see a similar application being used for inside and outside applications. So for example, inside, I'm thinking doing inventory management in a warehouse. So the ability to differentiate even with small text or changes, that's really a big deal, and making sure that you reduce some of the human error that could happen with appropriately managing your assets. As well as outside, I'm thinking like there's more and more ways to collect data, whether it be from drones, security cameras, or just a foreman walking out with a cell phone and taking images. Being able to automatically identify and classify different asset types, and making sure that you've got a consistent log of your assets and equipment on site.
And that's great. And you brought up a great point. Not just even though we show this in a couple of images, but this also works with video. So if you have a video stream, then correct me if I'm wrong. With a video stream, we can even be more accurate with some of this object recognition.
Yeah, because if we have a video, you have redundancy of data, because say you have 30 frames per second, a lot of those frames are going to be very similar. Probably the angle is going to be changing slightly, so you have more information, so you can potentially aim at a higher accuracy.
Okay, so moving quickly to another demo. So I'm overloading everyone with tons of demos today. So in this particular demo, we are basically able to very quickly identify images that got uploaded into the systems and classify them good versus bad. And for this particular use case, the original intent was really to help reduce the work necessary for persons to go spend a lot of time and resources to identify good versus bad pictures. So maybe I'll show you. Well, I'll show you a couple of unique things that we can do here. So obviously once we identified good and bad, there are actually a few things that you can do. So for this particular imageries, we can actually go ahead and enhance them. So as you can see here, it's actually quite dark, but the compositions of this picture is probably still good. So why don't we go ahead and use AI? So this is sort of like a automatic Photoshop to go and enhance the picture. And within a few seconds or so, you'll see a fixed picture on what it will look like. So you may not be able to tell very quickly, but I happen to have a screenshot earlier to show you the difference. So before the enhancement, you can barely see a bicycle on this pillow and also a flower pot here. But once we enhance it, you can very clearly see the bicycle and the flower pot on this picture here. And not only that, we can actually, on a bad picture, make recommendations on why this is a bad picture. Obviously, when you see this, it looks like a bedroom, but this may not be an appropriate bedroom picture because it doesn't entice someone to actually look at it and say, oh, well, I want to stay at this maybe bed and breakfast location. So when you click recommend, we can actually provide recommendations on what a good bedroom picture framing should look like. So there are a number of technologies going on here, and maybe Ben, you can share a little bit about what we are doing. So earlier we talked about using two pictures, but in this particular scenario example, this is also being able to help customers reduce the time it takes for data cleansing and data preparations. Maybe you can share a little bit more.
Yeah, so I think this was a perfect example of machine learning learning a concept that is difficult for a human to articulate. For example, we might have some sense about whether a picture is good or bad, but it might be difficult for us to articulate why the picture is good or why it is bad. It could be the composition is good, it could be the angle of the shoot is good, it could be the color histogram is good, or the lighting condition is more appealing. It could be a lot of different factors which are kind of hard to really articulate for each of those images. So what end up happening in our system is we don't need human to identify all those different factors that is affecting their decision. They just need to tell us which picture they think is more appealing, which picture they don't like. And after we have the data set, it is purely a data-driven approach. Based on the data, we're able to learn this engine that is able to separate the good ones from the bad ones. So that's the first step we're doing here, which is totally data-driven to learn a concept that is hard to articulate by human. The second part is that you see the example Victor showed of enhancing one image. This is so this is done by doing collecting those two sets of images. The first set is the original image. The second set is the image that after human processing. So after we have those two sets of images, you can think of our function as similar to a automatic Photoshop. So it's going to learn how people are changing the images from bad ones to a better ones. So it's going to learn this process automatically. And after it learned this concept, it is able to automatically apply those enhancements to images without any human intervention. You can think of this as human editor of the images. They're training the system to do this automatic Photoshop. So those are the key technologies that we use to make this happen.
Wonderful. Christina, what do you think?
So again, this is not an industrial use case, but I'll make some leaps of where it could go. So first off, being able to have good quality images, and sometimes whenever you're out in the field, things aren't always super clear. And so being able to automatically enhance those definitely provides value. Just to have a clear and reputable source of information changes over the course of time, and how a certain site looked at different times in your backlog. Also, whenever it comes to classifying good versus bad, I think that this is the more important feature here. So being able, first off, to identify things like safety hazards, unauthorized activity, even whenever it comes to classifying different components within the images, being able to look a step further and being able to see things like leak detection on pipelines, potentially, like I'm thinking power and utilities, being able to see vegetation encroaching on a power line, and then being able to flag those for operators or whomever is the critical stakeholders there.
Great. So thanks. And because of time, we'll go ahead and show this final demo very quickly. So NLP is actually one element that is quite difficult in a number of cases. So we actually built this function where you are able to upload a set of data, and we can quickly understand the data and being able to identify information in there. So sort of like a smart natural language search. So what I have here is actually a set of data in Japanese. In most other solutions out there, you have to train the data in its appropriate language. So if your data set is in English, you have to create the English intent in order to help customers to find the right answer. And in this particular example, I actually have a Japanese data set. So actually, let me type in my questions in English. So this is I think of this data set is actually about vehicles. So we grab this data from a vehicle manufacturer. So a user or a customer support person wants to get a call from a customer and may type in, how do I change the AC filter? So you notice that the answer comes back in Japanese, even though the data is not trained in English, but we are able to use English to identify the language in Japanese. Just to make sure I show you that we are not cheating, I have Google Translate up here, and I'll go ahead and quickly enter the information. You can see that despite us just typing in, how do I change the AC filter, is able to identify the right information in Japanese and pull the information out for you. And we're able to do this in a matter of seconds. Once you upload the data set, we can support up to 2 million lines of data, and we're able to find information quite rapidly. So Ben, maybe you can help us understand how can we do this very quickly, and how are we able to do this without using keywords?
Sure. So I think this is a good example of where we let the machine learning system, when we're doing training on the system, we do the heavy lifting. So what happened here is actually when we train our models, we actually train on the Wikipedia data. So we're collecting Wikipedia English, Wikipedia Japanese, and also the Chinese, although different, more than 10 plus different languages version of the Wikipedia. We put all those data together, and then we train the system. So what happens is that, first of all, the system is able to learn human language. It is not requiring to have a lot of customer data for the system to train, because the system already understands, for example, the English language, the Chinese language, the Japanese language. So it is able to connecting the dots. Say when someone says AC, it means air conditioner. It is able to connecting the dots between those concepts. And because we are training a system by combining all those different versions of the Wikipedia in different languages, we're able to train the system to understand cross language. So by doing those two things, we're able to facilitate the function of, first of all, it's not keyword based. It's able to understand what the intention the customer really has. And the second thing is that it is able to understand multilingual and connecting the concepts through different languages. So those are the two functions that we're building our system based upon.
Yeah, and then one of the key things that we sort of highlighted earlier in the image detection demo is that let's say you have a new employee who saw a defect, and doesn't understand how to address that defect. And maybe his or her vocabulary with regards to that particular defect is still not that quite clear. That person can enter a text trying to describe what it is, and without even using the keyword, the industry keyword, is the system the right information from there to be able to pull the documents or point to the right information so that the operator or the users can find the right information for him or her to do the work. So one more very quick thing. We have actually built this very simple chatbot for our employees to use because of the coronavirus. So this is an internal Petuum only tool for employees because internally we have a lot of questions. Information is pulled from the CDC website. Let's say I want to ask, tell me about symptoms. So it will actually show me information very quickly about the different potential symptoms. And I can also look at related questions on symptoms as well. Maybe I'll ask another questions about how many cases in California. It will actually point me to information about what the state of California is doing. So I'm able to identify the related questions based on the types of information or questions that I'm asking. So a very powerful natural language processing tool that we are able to provide here.
Great, Victor, and just a quick time check. We've got about 5 minutes remaining.
Yeah.
So just a quick reminder to everybody, you will be prompted at the end of this webinar to fill out a questionnaire, that survey. And then also, if you want to continue conversations with us, if there's something that sparked your imagination and you see a potential use case at your business, you can always contact us at business@petuum.com. On the website, we've got like a chat function. You can live chat me if you want to just learn a little bit more. And yeah, Victor, any closing thoughts before we open it up to questions? I see a couple of them coming in here.
Yeah, no, this is great. I mean, we've thrown a lot of demos at you, really to show you the art of the possibility on how they can be applied in the different industrial area. So we hope this is helpful. And why don't we jump into some Q&A questions?
Great, I already have a couple coming in here. Excuse me. So to follow up on Ben's explanation of the most recent, the chatbot demo. So does the Wikipedia language training mean it's using Wikipedia in page linking? As an example, the knowledge graph to avoid keyword use.
Sure. We're actually not using the knowledge graph part of the Wikipedia. We're just using the text document. So it's only the pure text information on Wikipedia. So you can think of this as throwing all the text documents to the system, and the system is able to understand what is happening in those documents and trying to infer what the human language is actually, how the human language is used. Like if you say first 5 words, what is most likely to be the 6th word, what's most likely to be the 7th word. So we're training the system this way. So it's not based on the knowledge graph that we extract from Wikipedia, but the pure text part.
Great, thank you. So here's another one here. People are asking, what do you do if you don't have enough or the right kind of data?
So I think the key here is that, first of all, we acknowledge that it's actually a very common case. That's why we focus our efforts in terms of how do we deal with small data. So I think the most often cases is that you want to find some similar use case. So for example, in dealing with images, it is often the case that you can say, for example, we're dealing with defect detection. There might be a very specific defects that this factory is operating, this factory is seeing. They might not really have a lot of cases of this specific defect happening, but across different industries, Even though there are different defects, they're different industry, but visually they might look similar. So we can actually utilize the images we collected from other industries to help the detection of these specific defects. So I think the short answer is that we're trying to collect similar images or similar data and do a knowledge transfer between other use cases to this new use case.
Great. Another question here. How long does it take to implement your solutions? I can take a first stab at that, and then you guys can add on. So I'd say that it really does depend on the complexity of the use case and what you're trying to solve. And so for some of the demos that Victor gave, like the chatbot, sometimes that can be created and able to use in under an hour. And for the Petuum Optimum example, for cement coolers or other types of predictions and forecasting and optimization, we've seen results even as short as 4 weeks time, being able to train those models and get them up to the prediction stage. Ben or Victor, anything to add on to how long it takes to implement?
Yeah, I think it's really case by case, because for different use cases, the complexity is different. It's mainly surrounding the software engineering piece. So for example, for the chatbot, it's our customer can see initial results probably within a couple of minutes. And for some of the more complicated cases, we need to do a consultation to make sure we understand fully of all the details of the use case. So I think the answer is it really depends.
Yeah, of course. One more question here. It's a good one. So when do you need to retrain your models, and how do you go about accomplishing that?
So I think the key of any machine learning system is you want a system to keep improving. The more data it sees, the system is supposed to be better. So what we do is that there are two ways. The first way is that we do this regular update of the model. For example, we can do this every day after collecting the log, after collecting the data, we refresh the model. That is one way. The other way is that we're also monitoring performance of the system. Once we see if there's a drop in performance of the model, then we would automatically trigger the retraining. So those are two ways we're implementing.
Yeah, and so to build on that, Rolando, to answer your question, it is not a static environment. So we're continuously learning, we're self-learning, we're continuing to evolve and improve the performance of those models over time. And that again falls back to the Orchestra platform and the capabilities that lie there. Alrighty, folks, we are just now coming to the end of the hour. I don't see any more questions coming in. If you guys do have any follow-up, please reach out to us. This recording will be available. And again, I ask you to take that survey whenever you're prompted at the end of the session today. Great, guys.
Yeah,
thank you so much. Yeah, take care. Stay healthy and happy.
Stay safe. Thank you.
Bye.